Welcome learners for the lecture 17 of a differential geometry. Today we discuss about the theorem that will be depending on the direction coefficient. Okay. Previous lecture we discussing about the two definition in the form of a direction coefficient. Then after that theorem what will we say about the theorem? If Lm and L dash M dash are the direction coefficient of a two direction at a point P on the surface and theta is the angle between two direction at a point P. Then cos theta equals to E L L dash plus F L M dash plus L dash M plus G M M dash. Okay, this is the first point. After that sin theta equals to H L M dash minus L dash M. Okay, let us go. If Lm and L dash M dash as the direction coefficient of a two direction at the same point P on the surface and R equals to considering or the corresponding to the unit vector along this direction. Okay. You know that A equals to L R1 plus M R2 and A dash considering as a L dash and M dash in both of those point. Let theta be the angle between two direction measuring theta from the direction R1 to R2 through the smaller angle. We have considering to the form A into A dash cos theta A cross A dash equals to sin theta n. Then A into A dash equals to L R1 plus M R2 L dash R1 plus M dash R2. Then we consider L dash, both of this multiply to each other, that will be generated LR1 into L dash R1. Okay, they considering to the form R1 square because both of this same and L dash plus L M dash plus L dash M R into R2. Okay, R1 into R2 considering not a same condition will be generated M into M dash R2. Then using equations second and third we get cos theta equals to E L L dash plus F L M dash plus L dash M plus G M M dash, both of this considering. Then A cross A dash equals to this point. A into A dash will be multiply both of each other when given to the form. Okay. Since R1 into R1 equals to R2 into R2 equals to 0, we have considering to the form A into A dash equals to L M dash minus M L dash R1 into R2 will be considering. Then using R1 into R2 for the NH, above equation will be given to the form that will be multiply R1 into R2, put up to the value of this form and generated to the equation from equation 2 and 3. Sin theta equals to L dash minus M L dash H. You know that H equals to square root of a EG minus F square. They considering to the direction and orthogonal to the form. Two direction is orthogonal, then cos theta will be generated 0. This term of the condition with the coefficient that will be generated, that is a E L L dash plus F L M dash plus M L dash plus G M M dash equals to 0. Okay, this will be the all theorem will be considering. Let us go next definition in this form. If Lm are the direction coefficient of the direction at a point P on the surface, the scalar lambda mu which are proportional to Lm are called as the direction ratio of the direction. Okay, let us go next theorem. If L dash M dash are the direction coefficient of a line which makes an angle pi by 2 with those line direction coefficient or the Lm, then L dash equals to minus, no, 1 by h will be considering 1 by h L f of L plus Gm and M dash considering 1 by h El plus Fm. Okay, what is the proof of this direction coefficient? If Lm and L dash M dash are the two direction at a points on the surface, then theorem will be given to the first form, that is a cos theta equals to E L L dash plus F L M dash. This will be equation generated. This is equation first, and sin theta equals to H L M dash plus L dash M. Okay, this is equation second. When theta equals to pi by 2, we have to the form E L L dash plus F L M dash plus L dash M plus G M M dash equals to 0. This will be considering to the equation if common to the form L dash M dash both of this condition, then above equation is satisfied through that condition, that is a L dash equals to minus A F L plus G M, M dash equals to alpha will be considered E L plus F M. Both of this condition is the same, but opposite direction will be generated as a sign, minus sign will be generated. Okay, then for some alpha we have to find to the equation, you know that angle will be considering to the 90 degree, theta will be generated as a pi by 2. We have to the form, then put up to the equation to h equals to lm dash minus l dash m equals to 1. Okay, using 3 and 4 we obtain to the equation that will be considering, put up to the value of all angle as well as to the form h l h into L will be generated to the form alpha EL plus FM plus HM alpha FL plus GM equals to 1. You know that give to the equation 1 by alpha equals to H EL square plus 2 FML plus GM square. Since LM are the direction coefficient to given as a point EL square plus 2 FML plus GM square equals to 1. So that alpha equals to 1 by H. Because this above equation will be generated to the form, both of these multiply to the form. Okay, put up to the form, that is a 1 by alpha. Alpha will be considering both of this cancelling to the form, not a multiply of the form, because alpha equals to 1 by H. Okay, this will be cancelling and given to the using above equation of alpha in equation 3, we get it as a form L dash equals to minus 1 by H FL plus GM and M dash equals to 1 by H EL plus FM. If LM are the direction coefficient of the tangential direction to the curve, U equals to UT and V equals to VT at the point surface, R equals to RUV, then it is differentiated to the form, that is a du upon ds m equals to dv upon ds. The unit tangent vector at a point P on the curve is given as a t equals to du upon ds. Above equation will be given. Okay, then two form will be generated. R is a constant with respect to s and uv will be generated. Then partial derivative will be considering, that is the form partial differential equation that will be generated. Del r upon del u into du upon ds plus del r upon del v into du upon ds. Okay, you know that del r upon del u is a r1 and del r upon del v is a r2. Then put up to the equation. See, dr upon ds represented to the unit vector p along the tangential direction to the curve. Okay, its component du upon ds and dv upon ds give the direction coefficient of the tangent on the P surface. Hence we given as a L considering du upon ds, M considering dv upon ds. Then put up to both of this value in a du into dv in the proportional to du upon ds and dv upon ds. Its direction ratio will be generated to the form in curve. Then equation 3 will be generated, sin theta, all of this value will be putting to the equation. Okay, sin theta equals to h du to delta v minus dv upon delta u. Square root will be considering, that is a form, square root of a e du square plus 2f du dv plus g dv square. Square root, same equation will be given to the form. Okay, cos theta will be generated to the form f du delta u plus f dv. Both of this equation will be equation 3 is generated. Then if the equation of a curve on the surface r equals to r uv is given to the implicit form phi uv equals to 0, then generated phi 1 and phi 2 in the direction ratio of the any tangent curve. Differentiate the equation of the curves phi uv equals to 0. We obtain delta phi upon delta u du plus delta phi upon delta v dv equals to 0. So that du upon dv equals to minus phi 1 upon phi 2. Okay. Hence, du upon dv are the proportional to minus phi 2 phi 1, using as a equation phi u and minus phi 2 phi 1 are the direction ratio of a tangential curve will be given in this form.